Good day, everybody, and welcome to James's explanation on how to work out outstanding balance in financial maths. This is normally grade 12 level type of financial maths questions, and we do definitely need to know this, typical exam questions. So what we're going to do is we are going to explain both ways or methods to work out the outstanding balance, and the two methods are the future value annuity method or the present value annuity method. Now, the future value annuity method is the difference between the two methods, should I maybe start there, is the end value. Now, your future value method deals with payments made to date. So let's put a scenario in place here. Let's say we've got a 20-year loan, and we are saying, okay, we start our loan at T0 and we're ending it at 240. We're also assuming that we're obviously making monthly payments to pay back this loan. And we've now started this loan process. One day you also take out a loan and you've been making payments, let's say for 90 months. And you're like, okay, cool, bank, 90, I want to know how much more I still owe you. And that's exactly what outstanding balance means. You wanting to figure out the outstanding balance, the money you still owe the bank after paying your monthly installments over a certain amount of time. So in this specific scenario, we're going to be working with 90. So we want to know what is our outstanding balance at 90 months or after 90 payments. Now, the future value method deals with payments made to date. So that's the difference. The end value is payments made to date. Okay, so that would be N is equal to 90. You've made 90 payments to date, which means you will be using 90 as your end value for the future value method for working out the outstanding balance. And the formula for this, guys, is going to be, it's quite a big one, it's quite a long one. I would also call it the one that works for every type of scenario, but we'll get into that a little bit later. So outstanding balance is equal to P1 plus I to the power of N minus X 1 plus I to the N minus 1 all over I. Now, yes, you guys are correctly assuming that these are a combination of certain formulas we've learned throughout our financial maths journey. Now, how this is actually broken up is that this part of the equation is the value of your loan with interest. And this part over here is the payments you have made with interest. That makes quite a lot of sense, because at the end of the day, what's happening for the future value method is that you're taking how much your loan has grown over 90 months in terms of interest, and you minusing the amount of payments you've paid over 90 months from that value, and whatever's left over is what you owe the bank and what is outstanding. So that is the future value method of the outstanding balance. Now, the P value stands for your initial loan. So let's just put a bit of a note in here. Initial loan. And then obviously your X is going to be your monthly payments, right? Okay. But at the end of the day, that is our formula we need to focus on when we're doing the future value method. And then obviously our end value is going to be 90 in this case, because it is your, let's just highlight that in a different color. That is the payments made to date. So 90 N is equal to 90. Okay, awesome. That is your future value method. Let me make a little bit of space here. So let's do that. Let's do that. Fantastic. Okay, great. So let's look at the present value method formula. So present value method, that is dealing with payments yet to be made. Remember, I told you at the beginning of this video that the difference between these two methods is the end value. So the first end value is payments made to date. The second end value, which is for the present value method, is going to be payments yet to be made. Now, how many payments, if you've made 90 payments, how many more payments do you have left? Well, it would be 240 minus 90. So that would be 150 payments that are left to be made for the remainder of your loan. So that is the N value we're going to be using here. So N is equal to payments yet to be made. Okay, now this formula is a lot shorter and it is a lot easier. So the outstanding balance for this is just going to use your present value formula. So it's just going to be x, open square bracket, 1 minus 1 plus I to the power of minus n all over I. The only difference here is that the n value is now going to equal. So this n value is going to be this n value here, payments yet to be made. Now, a lot of you are most probably thinking, well, James, this is a much shorter method. Why can't I use this every single time? Good question. We can only use the present value method when we know that our end time, so when we're going to finish our loan period, is a solid number. Okay, so say, for example, you get given a formula or a question where you have to solve for your N. You've been given the amount of money you're going to be paying every month. You've been given the loan amount, and they're asking you how long will it take for you to pay back this loan. And then you solve for N, and then we have to use logs and so on and so forth. But our N value is going to be a decimal, which means that you're going to make a certain amount of full monthly payments, and then your last final payment will be something smaller than that. So what I'm trying to get at is that your N value, if you want to use your present value, and this is quite important, your end value of N must be a whole number. There is ways of obviously storing it in your calculator and so on and so forth, but now I'm trying to make it easier for everyone who doesn't know how to store on calculators, that your future value method will always be your method that will work for every scenario, and then your present value method will work if your end value is indeed a whole number. So at the end of the day, both of them are going to work, but like I said, scenario is specific. The present value method, the reason why, so another question people ask me is, James, but now why must I remember the present value one? Why don't I just remember the future value one if it works for all of them? Look, when we get to matric, we also need to think about strategy and time we're taking in our exam. So at the end of the day, if you can use a faster method to get through the question, that's saving you time, which allows you more time for the difficult questions that are going to be presenting themselves later in your papers. Okay, but that's a fantastic note. You're giving you a bit of time to write that down. You can obviously pause the video to also write it down. But those are your two methods. Now let's put these methods to test or to practice. I've got an example here. A loan of 50,000 at 12% per annum compounded monthly will be fully paid at the end of 5 years. Determine the value of the equal monthly payments. Okay, great. So that is a straightforward, we're dealing with a loan, which means we're dealing with a present value annuity formula. So let's write our present value annuity formula out. X, open bracket, 1 minus open bracket, 1 plus I to the power of minus n, close bracket all over I. And we are now going to work out our equally monthly payments. So present value is our present value loan. So that's 50,000. Equals x, which is what we're trying to figure out, 1 minus 1 plus I, which is your 12% over 12, close bracket to the power of 5 years, so it would be minus 5 times 12. Remember, if we're dealing in months, everything has to be in months. Oop, that's a horrible line, James. There we go, and that is over 12% over 12. Okay, now we're going to do a little bit of algebra and make x the subject of the formula, so it's going to be 50,000, open bracket, 12% over 12, all over our big bracket, which is 1 minus 1 plus 12% over 12 to the power of minus 60. You can make that simplified just to make your calculations a bit easier. Now, if you put that into your calculator, you are going to get monthly installments of 1,112 Rand and 22 cents. Remember, guys, in financial maths, we always round up to 2 decimal places. Okay, fantastic. So that is now our first question. We've got our installments. Great. Now the next question is saying determine the outstanding balance immediately after the 20th payment using both methods of calculating an outstanding balance. Now, just before I start this, there will be a little bit of a discrepancy with our answers. Reason being is because we have rounded up this value over here. But the discrepancy is not going to be very big. It's a matter of cents and maybe R1 here or there. And when you guys are doing your practice, the scopes and the memos normally do give an allowance of a few cents to R1 or R2 discrepancy. So don't worry about that. But let's prove that these two methods will work. I'm just going to zoom out a bit and let's go ahead and start 1.2. So the first thing I'm going to start off by doing is writing my timeline. So we have T0 and my end goal is T60. First thing I'm seeing, my end time is a whole number, which allows me to use my present value annuity method to work out my outstanding balance. Okay, so what do we got now? We now have T20 is what we're going to work out, our outstanding balance. So do you agree with me that this is my future value method? This is my present value. My N is going to be 20 here. My N is going to be 60 minus 20, which is 40. Okay, so let's do the first method. My outstanding balance is equal to, I'm going to write the formula out so that you guys can also try and get it into your head. They unfortunately don't give you these in the test, so you need to learn them off by heart. All over I. Okay, so the outstanding balance is equal to the 50,000 open bracket 1 plus 12% over 12 to the power of 20, because my N value for my future value annuity method is 20, minus X, which is the 1112,22 open square brackets. I'm going to run out of space here. 1 plus 12% over 12 to the power of 20 minus 1, close my square bracket, all over 12% over 12. Okay, therefore, my outstanding balance using my future value method is going to be 36,519,33. Okay, then that is obviously my future value method, right? Let's just put a little bit of a heading there just to know that we're doing that. Okay, the next one is going to be my present value method, and that is going to be outstanding balance equals X, and then it's just my present value annuity formula. Okay, therefore my outstanding balance is equal to 1112,22 square bracket, 1 minus 1 plus 12% over 12 to the power of minus 40, close square bracket, all over 12% over 12. Therefore, for my present value method, my outstanding balance is going to equal 36,519 Rand and 39 cents. Remember what I told you guys about the discrepancy? It's out by about 6 cents, which is not a problem. So I did a lot of fast calculator work. Another reminder that you please need to be careful when typing stuff into your calculators. Silly mistakes do pop up when we try and rush. So don't let that be the downfall for you to get your marks calculator work. Take your time on it. If you're confident with your calculation, take your time plugging it into the calculator. And that is how we work out outstanding balance, guys. I hope you enjoyed the video. Please click subscribe if you want to see more, and look forward to seeing you guys next time. Great. Have a good one.